So this is Grayson. He just wanted to say hi to everybody. He's my special guest for today. Can you say hi?
Hi.
Is there any message you want to pass on to my students?
I'm in kindergarten now, and this is there. Tomorrow, I have to skip school because I have throat problems.
All right, can you say bye to everybody?
Bye.
Hi everybody! Today's learning goal is going to be about multiplying and dividing integers. So the last video we talked about adding and subtracting, and now we're talking about multiplying and dividing. So it goes with the same learning goal. Recall that we talked about in the last video, if we add two negative numbers together, so in this case if we add -3 plus -3, that the answer is going to be negative, that those negatives will just come together and that they will get along and nothing will cancel anything out, and so that will be -6. Those two negatives add together and make an even more negative number. And you may remember when you first started learning about multiplication way back a long time ago, you learned that multiplication is basically just a shortcut for addition. If I'm going to be adding the same number over and over again, then I might as well multiply. So in this case, instead of writing an addition problem, I could write this as a multiplication problem. So I have two groups of -3, and those are two groups of the exact same size. So that is the same as saying I'm doing -3 times 2, and so you'll notice I still better get the same answer because those two problems mean the same thing. -3 plus -3 and -3 times 2 will give me the same thing, so I'll get -6. So this kind of leads us to notice one thing about multiplying and dividing integers. When I multiply a negative number times a positive number, my answer is going to be negative. And remember, we talked about for multiplication and for addition, we have that thing called the commutative property that says I can flip the numbers around and I'll still get the same answer. So I could rewrite this as 2 times -3, and I would still get the same answer, -6. So it doesn't matter which of those two numbers, whether it's the first number or the second number, is negative, I'm still going to have a negative answer. Well, then you might be asking yourself, well, what if the smaller number is negative? Is my answer still going to be negative? Because when we were adding a positive and a negative number together, it depended which one had the larger absolute value, whether the answer was positive or negative. So if I rearrange these same negative signs, now I have three groups of -2, and I could still write this as a multiplication problem. This would be +3 groups times -2. So I have three groups of -2. I'm multiplying those two together. And you can see if I count those up, I would still have -6. So it does not matter whether the number with the larger or smaller absolute value is positive or negative. That has no effect on the outcome here. If I multiply one positive number by one negative number, my answer is always going to be negative. And again, it doesn't matter what order those are in either. So I could rewrite this as -2 times 3, and I will still get -6. We've talked about what happens if you multiply a negative times a positive. We're going to get a negative answer. But what happens if I multiply a negative times a negative? Well, that's a little bit trickier, but it's still just a pretty simple rule that we can memorize. Three groups of -4 together, and we got -12. Okay, so if I take the opposite of 3, so instead of thinking of this exactly as -3, we're going to do a little trick and think of this as the opposite of 3. But remember, opposite numbers are just numbers that are the same distance away from 0, but in opposite directions. So the opposite of 3 is -3. If I take the opposite of this side of my equal sign, I would also have to take the opposite of this side of my equal sign. So what happens when I do that? Magic. Poof! So I take the opposite of the 3 over there. Now I'm multiplying that by -4, and magically my answer becomes positive, the opposite of 12. So all of those negative symbols became positive because we took the opposite. So strangely enough, and it is a little bit hard to remember, when you multiply two negatives together, you do get a positive. And that's not the same thing that happens when we add. So here's a rule for multiplying two integers together. I'm going to state this sort of the long way. It says the product of two integers with the same sign is positive, and the product of two integers with different signs is negative. So we're just getting used to these words. Product right here, and integers. Remember, we've been talking about what those are. So product just means the answer to a multiplication problem. So if I want to simplify this down a little bit, the easy way to remember that is that if I have the same signs, my answer is going to be positive, and if I have different signs, my answer is going to be negative. And so you can see, if I do just a normal multiplication, 3 times 2, I will get 6, positive 6. If I do -3 times 2, my signs are different, so my answer will be -6. If I do +3 times -2, again, my signs are different, so my answer will be -6. And then the little slightly weird one, if I do -3 times -2, the signs are the same again, so my answer is going to be positive. So what happens with division? Is it the same? If you think about division is taking a large group of something and divide it up into equal parts. So let's say I want to take all of these negative signs and divide them up into my buckets here. I have 15 negatives here, and I'm going to divide these up amongst these 5 buckets. So I'll just start dealing them out, putting 1 in each bucket. So I divide these up, and I end up with 3 in each bucket. So I would think of this as I started out with -15. I divided that by a +5 buckets, and I ended up with -3 in each bucket. So you can see here I'm dividing a negative by a positive, and I'm getting a negative again. So it's looking like our rule is probably going to be the same. Division is not commutative, so I can't just switch those two numbers around and say, well, there you get the same answer. And it's a little bit hard to think about having -5 containers that I could put something in, but it is going to be the same rule where if you have one negative and one positive, you're going to end up with a negative answer. So if I rewrote this as +15 divided by -5, which again is harder to imagine, but you would still have your answer of -3. And if I take -14 and I divide that up amongst 2 containers, you can see I'm going to end up with 7 negatives in each container. So -14 divided by 2, -7 will be my quotient. And again, if I switch those around, even though it doesn't quite make sense, so you can see that will still be negative. And you can see basically the same thing will happen now. If I think about taking my -14, and instead of dividing that by 2, now I divide that by the opposite of 2, then that is going to make my answer be the opposite as well. So I take my -7, I take the opposite of that, it becomes poof, magically all of my signs become positive. So I can see that I'm going to have the same rule here. When I'm dividing two integers, same signs gives me a positive quotient, and different signs gives me a negative quotient. So just in the same way that when I had 3 times 2, I got 6. Now if I do 6 divided by 2, I'm still going to have a positive. 3 positive divided by a positive is positive. And so forth. If I have one negative and one positive, my quotient will be negative. And if I have 2 negatives, my quotient ends up being positive. And this might be a good time to pause the video, use your pause patrol, and write these rules down in your notes. This is a really good thing to have written down. So at this point, you should Pause the video and answer the free response question. Pause the video now to answer the multiple choice question.